So with this warm up, all right. First things first, what I tell you whenever you start tackling a problem like this, what should be the first thing that you do? You got to factor. So in this case, you got to factor a couple times. And it's actually not as many times as you think. Because what's true about these three? Can I factor those three anymore? No. So those are done. We just got to factor this one, and this one. So really, you only had to factor 3 times. All right. Now, let's start with the green. So with the green, first off, what did I always tell you to do if you have one that looks like this? Flip it so the x is in the front. So I'm going to have this as negative x squared plus 81. And the reason I told you to do that is because now it makes it really easy to see that you have to do what first? Take out a what? A negative. Good. So this would be negative x squared minus 81. All right. So that's why I say always reorder it so that you can see to take out a negative first. Because I always told you guys, if there's a negative on the first term in the row or column or whatever, you got to take a negative out. All right. Now, what is true about this? It's a what? It's a difference of squares. So that means if I have a squared and b squared, so that would be x squared and 81. What do I need to find? I need to square root both of them and get a and b. All right, so what's square root of x squared? Square root of 81. And then how do I rewrite my factors? Right. So if I rewrite this, I have 6 over x minus 8. Of course. So I have 6 over x minus 8 times x plus 9, x minus 9. And we got to bring down that negative. So there's a negative, there's a negative right there. So that's the first factoring. Now let's do the pink one. So with the pink one, first off, what's something that we can obviously take out before we even start doing big X and everything? Greatest common factor, what is it? 6x, good. So each of these can be divided by 6. Each of these have at least one x because that's the smallest exponent over here. So GCF 6x. So I'm going to divide each of these by 6x. So the GCF is 6x, so I'm going to pull that out. So what I have left over is x squared minus 4x minus, what was it, 45, I think? All right. Now, the reason you always look for a GCF first is because now we have a very simple trinomial to factor now. So instead of having an a value that's greater than 1, we have one that is 1. So what do I do next? So to factor that trinomial, what do I do next? Big X. What goes on top? So we do a times c on top. So that would be negative 45x squared. What goes on the bottom? Negative 4x. We know that both these terms need to end in x so that we can multiply to x squared, add to an x. Now, since we're multiplying to get a negative number, that means one of our factors has to be what? Negative. So what are factors of 45? Where one of them is negative, that can add to negative 4. Negative 9, positive 5. So these are the two factors. What do I do next? Reverse box. What goes in the top left? X squared. Bottom right? Negative 45. What goes in the other two boxes? Good. And again, it doesn't matter which one you put. You could put the negative 9x where the 5x is. It doesn't matter. Now, from here, remember, you take GCFs from each row and column. So what's the GCF of the first row? Guys, please make sure you're off your phones. All right. What's the GCF of the second column? Or second row, I mean. 5. So that's plus 5. GCF of the first column? X. GCF of the second column? Negative 9. It started with a negative, so we got to make it a negative. So if I pull out all my factors, I have x plus 5, x minus 9. And what needs to go in front of it? 6x. Don't forget to put that GCF back in front of it. Then it's going to be times, we can put the x plus 9 back on the bottom because we don't have to factor that, but we still need to factor the blue. Now, the blue, does it have a GCF? No, so we can go straight into big X. What goes on top? Negative 40x squared. Bottom? Negative 3x. Both of our factors have to have x in them. And if we're multiplying to get a negative number, that means one of our factors has to be what? Negative. So our two factors of negative 40 that'll add to give me negative 3, or one of them's negative. Negative 8 and positive 5. Remember, if you don't know, just start listing factors of 40. So we have 1 and 40, 2 and 20, 4 and 10, 5 and 8. Ding, 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 we got a winner. If we make one of those negative, it'll subtract to give me negative 3. In this case, it'll be the negative 8. Now, if I set up my reverse box, all right, x squared, negative 40, negative 8x, 5x. GCF of the first row, x. GCF of the second, 5. GCF of the first column, GCF of the first column, x. GCF of the second column, negative 8. So my two factors are x plus 5, x minus 8. So I have factored everything I possibly can. Now, from this, you can start crossing out if you want to. But remember, I always recommend mashing them all together just so you don't forget anything. Now, if these are by themselves, you can always just put them around parentheses. They're still considered factors. And remember, I always say move any monomials to the front of the pack. So if I write this all out, I have negative 6 times x plus 9, x minus 9, times x plus 5, x minus 8, all over 6x times x minus 8, x plus 5, x minus 9, x plus 9. Now, again, you don't have to necessarily do this step. I just do it so it's really, really easy to see what you can cross. So, someone name me one thing I can cross. So we can do x minus 9. Those are gone. What else? X plus 9. What else? X minus 8. What else? X plus 5. One more. The 6's. Not the negative, just the 6. So, What am I left with? -1 over x. So we were left with a negative, with just a standalone negative. There's a 1 next to it, and x. So my answer is -1 over x. So guys, the hardest part about this is factoring. Once you get it factored, just cross, 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 done. All right. Any questions on that? All right. So today we're doing the other operations with rational functions, and that is adding and subtracting them. All right. So go ahead and take out that pink graphic organizer. You should already have it out. We're looking at the back side of it. So this is the current side. If you look at the back side, it's add, subtract. Now, first off, if you recall what I said on Friday, just like how multiplying rationals is pretty much the same thing as multiplying numerical fractions, adding and subtracting rationals is the same thing as adding and subtracting numerical fractions. So let's say I had 1/2 plus 2/3. Just as an example, 1/2 plus 2/3. Who remembers how to add fractions? What is the first thing you got to do when you add fractions? Find a common denominator. What would the common denominator be of 2 and 3? 6. So I'm going to make these so that they each have a denominator of 6. So what would I have to multiply to 1/2 to get a 6 on the bottom? 3. So I have to do 3 over 3. What would I have to multiply to 2/3 to get 6 on the bottom? 2. So 2 over 2. Once I have the common denominator, what do? Add what? Add the numerators. So the denominator stays the same, and we add the numerators of 7. It's the same thing with subtracting. You get common denominator, change it, subtract the top. So 7 over 6. Adding and subtracting is pretty much the exact same with rationals. And again, factoring is going to come into play here. I told you guys, I warned you before we started this unit. If you don't know how to factor, you're going to struggle. All right? That's why I say practice, practice, practice. If I give you those factoring practices in Delta Math, you need to actually try and do them, because otherwise, it's not going to be fun. So, first off, for both addition and subtraction, let's do addition first. So, first thing with addition, you got to find the least common denominator, LCD. Which, remember, LCD just means the smallest multiple of the denominators. So in this case, if we look back at the numerators, 6 is the smallest multiple that 2 and 3 can make. Another common denominator could have been 12, could have been 18, so on and so forth, because all those are divisible by 2 and 3. But 6 is the smallest number that is divisible by both 2 and 3. You factor each denominator. Each factor must be included in the common. All right. We rewrite each fraction using the LCD and multiply the numerator and denominator by the missing factor. Add the numerators, which it's really easy because it's just combining like terms. And then you always keep the denominator. So that's why you found the least common denominator. So in reality, you shouldn't really have anything that crosses out sometimes, because occasionally you have to check to see if the answer is fully reduced. So you got to factor the numerator and reduce if necessary. So like we do with multiplying and dividing. All right. After we reduce, if we can, then we're done. So this one's a little bit more step heavy than multiplying and dividing. All right. Now, something to note. If you have A over B, you can multiply A and B by C over C. Because you're basically just multiplying 1. If you have two fractions with the same denominator, you can combine them into one fraction, but you're just adding the two numerators. That's the other math law. Now, with subtracting, it's pretty much the exact same thing. The only difference is you have to change it to addition by distributing the negative across the numerator. So in other words, you got to distribute that negative. All right. So let's look at an example. So this first one. All right. So the numerators, can I factor the numerators any at all? So the top ones, can I factor? No. So all I got to do is factor these two. So that's the first thing I need to do. I need to factor them so I can find common denominators. Boys, stop talking. I love how I said stop talking and you just did not. So we're going to do the yellow one first. So big X, what goes on top? 20x squared. What goes on the bottom? Negative 9x. So we're supposed to have an x here and here. Now we're multiplying to a positive but adding to a negative. So what does that say about our signs? They're both negative. So what are two numbers that multiply to 20, add to 9? 4 and 5. Set up my reverse box. All right. We have x squared, 20, negative 5x, negative 4x. What's the GCF of my first row? X. Second row, negative 4. First column, X. First row, negative 5. So I have x minus 3 in my numerator. In the denominator, I have x minus 4, x minus 5. Plus. If this would right. There it goes. Plus. The 2 stays on top. Let's factor the second one, so the green. What goes on top? 8x squared, bottom. Negative 6x. So I have x, multiplying to a positive, adding to a negative, so both signs have to be negative. 2 factors of 8 that add to 6. 4 and 2. Then, so this would be x squared, 8, negative 2x, negative 4x. GCF of the first row? It's x. GCF of the second row? GCF of the first column? GCF of the second column. Good. So this would be x minus 4, x minus 2. Now, from there, we look at the LCD. We look for the LCD. Now, here's why I tell students with the LCD. It's actually very, very easy to find. We just want to write every factor between the two denominators once. All right, so if a denominator So if a factor repeats between the two denominators, we don't need to include it. I just want to write every factor in the denominator once. So no repeating factors. So the two that obviously don't repeat are x minus 5, x minus 2. But notice how x minus 4 repeats. All right, we only need to write x minus 4 once. Okay, why? Because that is part of our LCD. We can't just throw it out. But also, when we have to multiply stuff back to it, we just don't have to worry about it. It's already there. So x minus 4 is also part of our LCD. So again, we take down each factor that we see in the denominators. And again, if one of them or a couple of them repeat, you only need to write them once. Does everyone understand how I got the LCD? Speak now, forever hold your peace. Now, we got to transform these so that they have these denominators. So x minus 4 times x minus 5, x minus 2, plus x minus 4 times x minus 5 times x minus 2. So this is a matter of what's missing. So look at the orange fraction. Which factor, if you look at the denominator, which factor am I missing to make the full LCD? So if you look at this denominator and then you look at the LCD, which factor is missing? So if I look at this denominator and this LCD, I want it to look like the LCD. Which factor is missing? X minus 2. So we're going to multiply the top and the bottom by x minus 2. So this would be x minus 2 times x minus 3. Look at the second. If we look at this denominator, what is missing between that denominator and the LCD? X minus 5. So we're going to multiply the top and the bottom by x minus 5. So that'd be 2 times x minus 5. And we already have the denominator. Now, your gut instinct is probably going to be to start crossing stuff out. Don't. Because if you start crossing stuff out, you're just going to end up with what we started with. All right, it's counterintuitive. So what we actually need to do is do a quick box method here and a quick distributing here. All right, so either do a quick FOIL or quick box method. So I know you guys know how to do that, so I'm going to skip that part and just tell you what it is. So it's x squared minus 5x plus 6 plus, I'm going to go ahead and combine them as I do this. If I distribute the 2, so I did FOIL here. All right, so I did FOIL there. I'm going to distribute here. So plus 2x minus 10. It's still all over our denominator. Do not factor through the denominator yet. Just leave it as factors. Now, what can I do with the numerator? To combine like terms. So the x squared's by itself. I have my x's and my constants. So this would equal x squared, because there's nothing to combine with. What's negative 5x plus 2x? Negative 3x. And then 6 minus 10? Negative 4. All over x minus 4 times x minus 5 times x minus 2. Now, we're not quite done because we got to make sure it's fully simplified, meaning you need to factor the numerator if you can, sometimes you can't, and see if there are any factors you can cross out. So in this case, it should be factorable. So let's do a quick big X. What goes on top? Negative 4x squared, bottom. Negative 3x. If we're multiplying to a negative, that means one of the values has to be negative. So what are two factors of 4 that can add to 3? 4 and 1. In this case, the 4 has to be negative. So, quick reverse box. I have x squared minus 4x, 1x, and negative 4. DCF of the first row, x. GCF of the second row, 1. First row, or first column, second column, negative 4. So, I'm going to bring this down over here. This would be x plus 1, x minus 4, over x minus 4, x minus 5, x minus 2. Anything I can cross? The x minus 4s are gone. So your final answer should be x plus 1 over x minus 5, x minus 2. Now, you can leave this like this, and I'll be happy. But sometimes they may have it in the fully standardized form. So you can always do a quick FOIL or box method on the bottom. So another answer I could accept is x plus 1 over x squared minus 7x plus 10. And that's if I did a quick box method for the right there. So again, if you get to here, I'm happy, but either one of these I would accept. But if you can get to here, I'm happy. So again, that's a lot. I know it's a lot. All right. These are not like, a nice walk in the park. They're a pain in the butt. Okay. Any questions on the adding? All right. Let's try a subtraction one. So, first things first, with subtraction, the very first thing that you should do is change this to a plus and put the negative in the numerator of the second fraction. Now, if there was a bigger thing up in the numerator, you would distribute that negative, but since there's only a 4 there, we can just leave it as that. The reason that we do this is so we don't have to mess around with the negative. And now we go into factoring. So luckily for us, these two are very quick factors. So I have x plus 3. How can I factor 4x squared minus 1? Heads up, guys. Come on. I know this is not the most riveting, but got to get through it. What is 4x squared minus 1? It's a what? It's a difference of squares. So I take the square root of both and then separate those two square roots by pluses and minuses. So what would it be? 2x plus 1, 2x minus 1. Plus negative 4. What's the only thing I can pull out of 10x plus 5? A 5, a GCF of 5. If I do that, what am I left with? 2x plus 1. All right, now LCD. Remember, I want every factor present at least once in my LCD. So someone name me one factor that's in my LCD. 2x plus 1 is one of them. What's another one? 2x minus 1 and 5. And since 2x plus 1 repeats, I don't need that other 2x plus 1. I just need one of them. So that's my LCD. Now I'm going to convert my fractions so that they have those LCDs. So I want 5 times 2x plus 1, 2x minus 1, plus 5 times 2x plus 1, 2x minus 1. So, first fraction, what's it missing? So this first fraction, what's the denominator missing from the LCD? What is it missing? So between this and this, what's it missing? 5. So I'm going to multiply the top and the bottom by 5. So this would be 5 times x plus 3. Second one, what's missing from the current denominator and the LCD? 2x minus 1. So I'm going to multiply top and the bottom by 2x minus 1. So this would be negative 4 times 2x minus 1. So very easy simplifying from there because all I got to do is distribute. Don't even have to FOIL or box method. So I'm going to rewrite this with the denominator as 1. So 5 times 2x plus 1, 2x minus 1. Then I have 5x plus 15 minus 8x squared, not 8x squared, 8x plus 4. And then I just combine like terms. So the 5x's, the x's go together, constants go together. So on top, I got negative 3x plus 19. All over 5 times 2x plus 1, 2x minus 1. Now, even if we factor the top, is it even possible to factor the top? So is it even possible to factor the numerator? No, there's no GCF. It's not a difference of squares because they're both not even perfect squares. In fact, we don't even have an x squared. And it's not a trinomial, so we can't use big X. So we're done. So you can stop here at this one, or you can distribute the bottom. So if you distribute the bottom, remember, this is just 4x squared minus 1. And all you got to do is multiply that by 5. So if you distribute that, the other way you could write this is negative 3x plus 19 over 20x squared minus 5. Either one of these is acceptable. All right, so here's what I want you to do. In your groups, go to your whiteboards, try letter C. Yes. So go to your group boards, try letter C. I'll leave C up for a reference. So you're doing C.
turn. She doesn't give us enough passes. Show us how to do one, and then we have to do it.
Stand there and try to look pretty.
Like, I need more. And I also barely had any room to write in it. So I started like not writing stuff.
Oh, you got it. Oh, you got it.
Start by factoring the denominators. You can't get an LCD if you don't know what the factors are.
Did you make that close enough?
6 x squared plus 8 minus 20. That is our problem.
Almost knocked that over. I got scared. Why is it so loud?
Factor for LCD.
Yeah.
I know it's like, yeah, I would write it next time. No, I think you really do the figures for that, the p value of 0.
No, that's terrible. I was talking about. No, that's terrible.
Yeah, transfer the negative.
Oh, wait, yeah, you're right.
Okay, big.
That next square too.
What?
Put the font here.
You know what? It's all right.
This is our house.
Okay, wait, what's this?
Yo, you said X squared. Wait.
Where did the eraser and purple marker?
Purple marker is somewhere below here.
Let me know. This guy crouched and walked in. I can tell. And it's like math pose.
No, you look like you're using this shit. I'm tired. I slept 2 hours.
This looks right though. Jonathan. Come on. How did you get that? Where did all these parentheses come from? It's y'all just watching him like
I don't understand. I'm confused. I'm gonna be honest. I don't know what the fuck we're doing.
I don't.
No, I definitely.
Neither did Jonathan.
Aiden.
But I'm trying to. I don't.
Pretty much got it. Now you just have to So the LCD, look at the look at the denominator. To the
What did you do?
I thought it was like.
It's a difference of squares.
Hey guys, I'll give you guys about 3 more minutes. Looks like most of you are wrapping up.
This is ridiculous.
Factor one.
When will we ever use this in life? Two factor.
I delivered it, bro. Is it the same thing?
Excuse me.
I don't know why y'all are giving up. I haven't called time yet. It's a game of what's missing. Look at the original, look at the LCD. What's missing? All right, go ahead and have a seat. Check. So I didn't do all the big X's, but just check your factoring. So looking around, most of you are pretty darn close. At the very least, you got the LCD, so good job. Yes. All right, so any questions on letter C? All right, so here's what I want from you guys now. I want everyone to take out a sheet of paper. So I want everyone to take out a sheet of paper. If you need it, they're on the shelf. So we're going to do a couple more problems together. It's on the shelf. So if you need paper, it's on the shelf. All right, go ahead and write down that first problem. Just write x over, right here on the board. So do x over y cubed minus xy. Write that down. So these are simpler versions of the fractions. So these do not have binomial factors. The factors are more monomial. So first off, if there's no denominator here, what's the unspoken one? 1. So what would be the common denominator between y cubed and 1? Nope. That'd be the common factor. I want the common denominator. It should just be y cubed. Because you're looking for a number or value that both y cubed and 1 can be divided into evenly. At least the lowest one. Can y cubed be divided into y cubed evenly? Yes, it's 1. Can 1 be divided into y cubed evenly? Yes, it's y cubed. So that's my LCD. Another way you can think about it, just multiply them. If you can't come up with an LCD, just multiply them. So I want to change this fraction so that they have y cubed on the bottom. What do I need to multiply to this one to make y cubed on the bottom? Do I need to multiply anything? No. So I just leave it as x. What about this second one? What do I need to multiply to get y cubed on the bottom? Y cubed. So I have negative xy times y cubed. Now, if I combine some stuff, all right, that means I have y cubed on the bottom. What's y times y cubed? Y to the fourth. So I have x minus x y to the fourth. All right. Now, here's my question. Is there going to be anything at all that I can factor out of this to at some point get a y cubed on the bottom? Anything at all? Because technically the top is factorable, but if you think about it, is at any point I'm going to have a singular factor that says y cubed that I can cross out. What do you guys think? Yes or no? It's actually no, and I'll show you why. So if I factor this, first, they both have an x, so I can factor that x out. So I got 1 minus y to the 4th. Still over y cubed. Now, problem with this is a difference of cubes. Not cubes, difference of squares. So this would be x times 1 minus, or 1 plus y squared, because that's the square root of y to the 4th, times 1 minus y squared, all over y cubed. This is another difference of cubes, so I got to factor that too. So that would be x over 1 plus y squared times 1 plus y, 1 minus y, all over y cubed. Can I cross anything out because it's fully factored now? Can I cross anything out? No. So this is my final answer. So why I asked you, do you think at any point you can get a y cubed to come out? The answer is no. The only way you would have gotten a y cubed is if both of these had a y cube in their factor. All right. So that can save you the heartache of having to factor stuff, even though I knew for a fact there's nothing would cross out. Those are just things you got to ask yourself. Think logically. You'll save yourself a lot of time and heartache if you think logically about them. Any questions on this first one? All right, let's try the second one. So, let's think about this logically. Since there's monomials in the bottom, we're obviously not factoring anything. But, let's talk LCD. So we're looking at 15 and 3x cubed. Obviously, our LCD is going to have a what in it? It's going to have a what? So if we look between our last one and this one, what is guaranteed to be in the LCD? I'm not talking number. So if I multiply these two together, what is definitely going to be in there? X cubed. Now, you could multiply 15 and 3 together and get 45. That would give you a common denominator, but it's not the least. You'd end up having to simplify more at the end. So let me ask you this. Between 15 and 3, what's a number that can be divisible by both 15 and 3? So what is a number that can be divisible by both 15 and 3? So for example, 45 is 1 because 45 divided by 15 is 3. 45 divided by 3 is 15. But there's a smaller one than 45. What is it? Not 3. 15 can't go into 3. 15. 15 divided by 15 is 1. 15 divided by 3 is 5. All right. So between 15 and 3, my least common denominator is 15. Does everyone understand the difference between least common denominator and greatest common factor? Do I need to explain it? Because if you don't understand it, it's going to be rough. So, least common denominator. All right. Basically, you got to ask yourselves, if I'm given these two numbers, so 15 and 3, all right, I'm looking for numbers that can be divisible by 15 and 3 as well. So, for example, one of the easiest way to get a common denominator or a common multiple, as some of you may know, LCM, That's the other way for it. It's to just multiply 15 and 3. Because that'll give you 45. That'll at least give you a place to start. More often than not, when in doubt, multiply them together. So 45 divided by 15 is 3. 45 divided by 3 is 15. But you need to ask yourself, is there a number that's smaller than 45 that's divisible by 15 and 3? Well, if you think about it, 3 is divisible into 15. You can go into 15 evenly. And obviously you can divide anything by itself, right? So that's where 15 comes into play. Both of those can divide evenly into 15. So another example, let's say I asked you to find the LCD of 6 and 8. So completely off topic from what we're currently doing, but if I asked you to find the LCD of 6 and 8, what's at least a number that you can start with? So what is absolutely a number that can be divisible by both 6 and 8 that we can get right off the bat? Could I just multiply 6 and 8? Just give me somewhere to start. What's 6 times 8? Come on, guys, that's multiplication table. 6 times 8. 48. So 48 will work. Let's see if we can go lower. So think of a number that has both 6 and 8 as factors. Can we get lower than 48? What do you think? Not 2. 2 is a factor of 6 and 8. Okay, I look for multiples. Meaning that if you multiply 6 by times a number or 8 times a number, you get the same number. So you guys are still thinking factors. You're still thinking factors. So 48 is probably the highest that we can get. Just flat out multiply them together. 24 will work too. Because what's 24 divided by 6? 4. What's 24 divided by 8? 3. So again, I'm looking for a number that when you divide it by those two numbers, it goes in evenly. And I want the smallest one. Now, multiplying them together gives you a place to start. All right, and then you got to ask yourself, okay, 48 is kind of the max that it can be, the max LCD, at least the one that I don't want to go past. Can I get lower? All right, that's what you should ask yourself when you're doing numerical ones. Okay, let's try another one. Let's say, let's do 12 and 11. And 11. Let's do 12 and 10. Okay? So 12 and 10. What's a good place to start? So we can multiply 12 times 10, which is what? 120. So that's a good place to start. Can I get lower? Yes. What's another number that can work? 60. 60 divided by 12 is 5. 60 divided by 10 is 6. Can I get lower? No, I can't get lower. So 60 is it. So does everyone understand how to do that numerically? All right. When in doubt, multiply them together. All right. That's always a good place to start. So if you don't know where to start, multiply them together. All right. So that's why it's 15x cubed. And again, if all else fails, you can use 15 times 3, which is 45, as the common denominator, but it's not going to be the least one. So in other words, you're just going to have to simplify again at the end. All right. So now I'm going to change my factors. So I have 15x cubed plus 15x cubed. What's missing from here? So what do I need to multiply to 15 to get 15x cubed? x cubed. So this will be 4x cubed on top. What do I need to multiply to 3x cubed to get 15x cubed? 5. So that'll be 20 over 15x cubed. So if I combine them, this would be 15x cubed on the bottom, and then 4x cubed plus 20. Now let's ask ourselves, is there something I can factor out of 4x cubed plus 20? I could factor a 4. So that'll be 4x cubed plus 5. Anything I can cross out or simplify? Yes, no, maybe. It's definitely no. You can't simplify 4 over 15. The x cubes you can't touch because of that plus right there. So we leave it like this. All right, take a minute. Try this one on your own. So try that one on your own. Figure out the LCD. Transform your fractions. Then add them together. It's always a busy Oh, by the way, it's in your best interest to write these down. Hint, hint, wink, wink. So it's always a good place to start the manual study. So it's always a good place to start the manual study. Yeah. Whatever the exponent is, just whatever the highest one is, just slap it on there. You can't get lower than 6. That's too easy. So now you gotta make both of these fractions have that. So it's always a good place to start. So what I just did before, it's the easiest way to get a least common factor. We multiply together, right? Right, to start there. Yes. Even if they're dead wrong, at least you try. Better than just sitting. Because remember, I can't take the EOC for you. All right, thumbs up if you're ready. All right, for time's sake, I got to move on. So, first off, LCD. What do you guys think it is? 6x squared. So, since it contained an x squared that obviously had to be there, then I told you guys for numerical, start with multiplying 2 times 3, 6. We definitely can't get lower than 6. All right. So, I'm going to change these so they both have 6x squared in the denominators. So, what do I need to multiply to the first fraction to get 6x squared on the bottom? You multiply 3 to it. So this would be 9 on top. But do I need to multiply to the second fraction to get 6x squared on the bottom? So how do I go from 3 to 6? Times 2. How do I get an x squared at the end? Oops. You slap an x squared on it. So you're doing 2x squared. So 4 times 2 is 8. What's x times x squared? X cubed. So if I rewrite these with them combined, I have 9 plus 8x cubed over 6x squared. Now, there's nothing in common between all those numbers. I can't factor anything in the numerator at all, so I'm done. Any questions? All right, we're going to do one more together and then we're done for today, at least. Now, this next one is a little bit ugly. This is what we call a complex fraction, which all it is you're combining, adding and subtracting rationals as well as multiplying and dividing them. All right. So here's the easiest way to do it. The easiest way to do it is to get rid of these denominators. And remember, if it's just a 1, the unspoken one's a 1. So we got to find an LCD for all 4 of those numbers. All right. So absolutely, what needs to be included in our LCD? X got to be included. Now, between 9, 3, and 1, what is the smallest number that can be divided evenly by all 3 of those numbers? It's 9. 9 divided by 9 is 1. 9 divided by 3 is 3. 9 divided by 1 is 9. So that's my LCD, 9x. So here's what we're going to do. We're going to multiply the top and the bottom by 9x over 1. So a little bit different than what we've been doing. But my goal is to cancel out the denominators. So I'm doing this to cancel out the denominators. So if I multiply dead across, what's 9x times 1? So 9x over 9, because 1 times 9, plus 9x times 1 is 9x. 1 times 3x is 3x. Still all over. What's 9x times x squared? 9x cubed. 1 times 9? 9 minus 9x, because it's just 1 over 1. Now we can start doing some simplifying. Boys, shh. So this first fraction, is there anything I can cross out? I can cross out the what? The 9s. What am I left with? X. What about this one? Is there anything I can cross out? The x's. What else can I do? What's 9 divided by 3? 3. So then plus 3 over. What about this one? Anything I can do? What can I cross out? The 9s. So I'm left with an x cubed. And then this last one. Nothing can cross out, but what's 9x divided by 1? 9. X. Now, a lot easier for us to deal with. Now this is a very easy simplification problem because what can I factor out the denominator? What's one thing that I can absolutely factor out the denominator? A GCF of x. So, still got the x plus 3 here. Got, oops, x times x squared minus 9. So if I divide both these by x, these go away. One of the x's on top go away. What's true about x squared minus 9? It's a difference of squares. So how do I factor that? Square root them. So what are the two square roots that I'm using? X and 3. So how do I write out my two factors? Good. Can I cross anything out now? The x plus 3's go bye-bye. What did I say you put on top if the factors on top cancel out? A 1. So this would be 1 over x times x minus 3. If I wanted to go a step further, I can always distribute 1 over x squared minus 3x. So the hardest part of a complex fraction is just getting rid of those denominators initially. So get rid of the tiny denominators first by finding an LCD, multiplying it to all the denominators, and then canceling them out. And then it's just simplifying. And we got time for one more. Let's do one more together. So another complex fraction. Make sure they all have denominators. So what's the denominator of this x, since there isn't one? 1. So I'm looking at all my tiny denominators. So the 1, the 2, 3s, and an x. So if we're talking LCD, guaranteed in my LCD is a what? X, as well as 3. Because between 3 and 1, the only number, or the smallest number that can be divided evenly by 3 and 1 is obviously going to be 3. That one's an easy one. So we're going to multiply the top and the bottom by 3x over 1. Now, I'm doing it over 1 so that we're not screwing with the denominators. All right? All we're doing is trying to get the denominators to cancel out. All right? So what's 3x times x? 3x squared. 1 times 1 is just 1. Minus 3x times x squared. 3x what? Cubed. Over 1 times 3 is 3. All over, what's 3x times x? 3x squared. All over 3. Minus 3x times 3. 9 over x. Or 9x, my bad. All right, so first fraction, 3x over 1. That just simplifies down to what? 3x squared. What can I cross out in the second fraction? I can cross out a 3. Those are gone. I'm left with x cubed. All over. What can I cross out with this first bottom fraction? 3. Have x squared left over. What about this one? X is minus 9. Now, I'm going to rewrite this top part so that the x cubed is first, just so it's in standard form. What can I factor out the top? An x squared. It's actually a negative x squared. Because remember, that first term's negative, got to factor it out. So I'm left with x plus 3. What's true about the bottom? How can I factor it? It's a difference of squares, so how would I factor it? X plus 3, x minus 3. What can I cross? X plus 3's. So my answer is negative x squared over x minus 3. Now, why I wanted you guys to write these down, guess what? I just did 5 problems of your Delta Math for you. You can just put them in. So, in your Delta Math, all right, you should have a new one. I did the first 3 that say add and subtract fractions, as well as the first 2 that say complex fractions. You're welcome. All right, so there should be no excuse why you don't get those correct. I gave you the answers. That's why I said write them down. So if you did as you were supposed to, you got some free answers.